All right, we're going to take a look at this 2-2 solving for a variable, the second part. This is more than one step. Okay, it's two steps in these situations. What we're going to do is we always want to move all variables to one side, all numbers to the other. So in this first part, problem 1, it says 4n, variable piece, plus the number 5 equals the number 25. So I want to move that 5 over to the other side to be with the other numbers. So how do I get rid of adding 5? I subtract 5 from both sides of the equation. That gives me 4 times n equals, that goes away, 20. Now I say to myself, hey, now it's just a multiplication problem. How do I undo multiplying by 4? I now divide both sides by 4, and I will get the value for the variable is 5. And you'll notice, if I come back to the original equation, 4 times 5 is 20, plus 5 is 25. Yep, that works. Problem 2. Okay, we have the variable 3n minus the number 1 equals the number 8. So let's move that minus 1 over off of the left side over to be with its number buddy 8. How do we undo subtracting 1? If somebody's thinking of something and they take 1 away, the way you move back is you add 1. So we add 1 to undo that subtracting 1. That's going to go away. I get 3n equals 9. And now I say, hey, I need n by itself. I don't want to know what 3 n's are worth. I want to know what a single n is worth. So I'm going to undo that multiplying by 3 by dividing both sides by 3. And that gives us n equals 3. And we can check it out. 3 times 3 is 9, minus 1 is 8. Yes, this is just a sequence of steps, an algorithm that we're using to solve each of these problems. Problem 3, I have the variable 5n plus the number 1 equals the number 21. How do we undo? How do we get, okay, sorry about that. How do we get the numbers together? Well, I'm going to get this plus 1. I want to move him over to the other side. To do that, I'm going to subtract 1. But if you subtract 1 on the left of the equal, you have to subtract 1 on the right side of the equal sign. This goes away. I'm left with 5 times n equals 20. I now say, hey, 5 times some number equals 20. How do I undo multiplying by 5? I'm going to divide by 5. And then that gives us our answer of n equals 4. 5 times 4 plus 1 equals 21. It works. 2 times n, take away the number 10 equals the number 20. So, as always, let's get all our numbers on one side, all our variables on the other. When we already have our variable to the left, we're going to move that plus 10 over to be with its other number on the other side of the equal sign. Those go away. We're left with 2 times n equals 30. Now I do the final step. I get rid of that multiplying by 2. I divide by 2. N equals, the board is slowing down, 15. Okay, n equals 15. I guess it wanted me to switch colors. It got upset with me. Number 5, 2n plus the number 6 equals the number 10. So let's get the numbers together. So we're going to subtract 6 from both sides of the equal sign. That'll go away. Here's my equal sign. I'm left with 2n on the left of the equal equals 4 on the right side of the equal sign. Now I'm going to get rid of that multiplying by 2 by dividing both sides by 2. I get n equals 4 divided by 2 is 2. One more. Number 6, 7n, take away the number 3 equals the number 18. So let's move that 3 over to be with the 18. That goes away. Here's my equal sign. I have 7 times n equals 21. I'm now like, hey, got all my variables on the left, got all my numbers on the right. I'm happy, but I want n by itself. I need to get rid of multiplying by 7. I don't want to know what 7 n's are worth, but what a single n is worth. So I divide by 7 to get rid of them. But whatever I do to the left, I do to the right. And I now get my answer, 3. And you can see 7 times 3 It's 21 minus 3, 18. We solved the equation. That's 2 steps. We're always getting the numbers over on the one side and then finishing out by dividing by whatever's in front of n so that we get a single n equals. There we have problems 1 through 6.